Welcome back to my YouTube channel. In the course of this video lesson, I'll be solving different practice questions that cut across the subject chemistry. Now, if you are just joining this community and you haven't yet subscribed to this channel, do well to click on the subscribe button and also give this video a like so you don't miss out when other videos are to be uploaded. So let's get into the first practice question, and it says an anhydride is an oxide of a non-metal. So they gave us different options. So what are they asking us to do in this question? It's very easy. They are trying to test our knowledge of what anhydrides are. So before I even choose the answer to this question, I have to explain what anhydrides are. Listen carefully, and it's actually very easy. Now, it must be noted here that anhydrides are non-metallic oxides. So this group of compounds called anhydrides, they are non-metallic. Okay, they are non-metallic oxides. Definitely, from the word oxide, it means that there is oxygen here. So non-metallic oxide meaning that we'll actually get a non-metal combining with oxygen. Then we will get what? An anhydride. Do you get the point? Because I just defined that anhydrides are non-metallic oxides. Simple. So we have to get a non-metal combining with oxygen. I hope it's clear. We have various examples of anhydride, like likes of CO2. Do you get? So in this context, the non-metal is carbon and oxygen is here. Do you understand? You know, oxygen is a diatomic element. So then it's going to exist as O2, diatomic, 2 atoms. Do you get? Not only this guy, we have other examples like the like of SO2. This is also an acid anhydride. We have other examples like NO2. This is also an acid anhydride as well. Okay, we have so many acids anhydride. So on this concept, you have to understand that acids anhydride, I just said that they are non-metallic oxide. When dissolved in water, they produce acid. So when we take any of these acid anhydride reagents and react them with water, then we are to form an acid. Do you understand the point? So let's take an example. This is carbon 4 oxide, which is CO2, and we've agreed that it is an acid anhydride because it is a non-metal carbon combining with oxygen. Do you understand the point? So this must be noted. So this, which is CO2, when reacting water, will get a very important acid, and the acid is H2CO3. Okay, and the reaction is balanced as well. This acid is called carbonic acid. Do you understand? It's called carbonic acid, and it is a weak acid. Now, even this NO2 is still an acid anhydride, but you must note this now. Whenever NO2, which we agree that it is an acid anhydride, reacts with water, we form 2 acids. This is why NO2 is not just an acid anhydride, but rather a mixed acid anhydride, because after reacting water, we get 2 acids, and that's how the reaction works. The acids are HNO2 plus HNO3. Do you understand? One of them, this specifically, is called nitrous acid, whereby NO3 is called nitric acid, which can also be called aqua fortis. That's the old name. So in summary, you have to understand that whenever acid anhydride reacts with water, we get acid. Put that in your mind, and we'll agree that acid anhydride, they are non-metallic oxide. That must be noted as well. Now, generally, let's talk about the properties of acid, because all these gotten now, they are acid. Remember, what is the pH value of acid? They are lesser than 7. This must be noted. You have to note that the pH of acids is lesser than 7. If we're to talk about bases, the pH of bases, they are greater than 7. So when the value on the pH scale is simply 7, it shows that that particular compound is neutral. And neutrality basically is seen most times in salts. Do you get? So I've said something that will help us solve this question. Option A. So they are trying to like define it. After they said something, they now said option A, which will not dissolve in water. Will acid anhydride not dissolve water? They will dissolve in water. So basically, option A does not even follow. They will dissolve in water. Do you understand? Because we said that when we dissolve in water, that's when we get the acid. Definitely, acid anhydride dissolve in water. This is one very important reactions of acid anhydride. Option B, whose solution in water has a pH that is greater than 7. We already agreed that, okay, they dissolve water, because option B agreed that it dissolves in water, because they said whose solution in water has a pH value that is greater than 7 is what I said. I said whose solution in water should have a pH value that is lesser than 7. This lesser sign, do you understand? That is lesser than 7. You can see that this greater, it does not work. Option C, whose solution in water has a pH less than 7. Less than 7. That's the answer to the question. The answer to this question becomes option C. Do you get? Whereby option D, whose solution in water has a pH of 7. No. 7 pH is seen most times in salt. Do you get? So that's for this particular question. So let's get into the next practice question. Now this must be noted. This reaction must be balanced for NO2 reacting water, because we had HNO2 and HNO3. So what do we do to balance this reaction? In this part of this reaction, we have 2 hydrogen, and here already we're having 2 hydrogen. So hydrogen part is balanced. So let's check for nitrogen. Nitrogen, we have 2 here. So how many nitrogen can you see here? We're having 1 nitrogen. So then I should put 2 in the front of nitrogen. Do you get the point? So moving further, oxygen now become 4. 2 times 2, 4, and we have 1 oxygen, that's 5. So then 2 plus 3, oxygen is 5. I believe you are following it. It's very, very easy. It's not difficult. So that is for that. Now let's get into the second practice question, and it says, what is the percentage by mass of oxygen in this compound? It's actually very easy. What they're asking us is to calculate the percentage composition of oxygen in this compound the way it is written. Do you understand? The compound here is Al2SO4 close bracket 3.2H2O. Very easy. So first of all, to calculate percentage composition of any element in a particular compound, we use the formula I'm about writing on the board, and the formula is simply this: percentage composition, which is that which we are asked to get in this question, is equal to atomic mass. Listen carefully, class. Atomic mass of that particular element they are asking us to get the percentage composition times number of atoms of that particular element times number of what we call atoms divided by molar mass of the full compound. Okay, molar mass of the full compound times molar mass of compound times 100, because we are looking for percentage. I believe you are following. So the next step to solve this question, follow me closely. First of all, I have to bring out all the elements making up this compound. And what are all the elements making up this compound? They are, the first one I saw is aluminum, Al. After aluminum, I saw sulfur. Just bring them out, identify them. The next I'm seeing is sulfur, or bring it out as well. Okay, and as you are solving this in JAMB exam, you have to be very fast. Okay, it's very easy. That's why practice makes perfect. Do well to watch all of these, practice them, because at the end of solving this question, I'm going to give you your own to solve so you can master this aspect. So the next element here I saw is oxygen. I'll bring it down as well. After oxygen, what was the next element I saw? Hydrogen. I'll bring it down as well. It's simple. And lastly, I saw another oxygen. Should I write it? No, we're written the oxygen. There is a reason I actually did this, so that it's very, very easy, like ABC, to solve this question. Now, first of all, you can see that they did not give us the atomic masses, because atomic mass was in the formula. They did not give us the atomic masses of each of the elements. Sometimes you'll be given in the exam, sometimes you might not be given. So it's important for you to know atomic masses of popular element asked in the JAMB exam or any chemistry related exam. And the atomic mass of aluminum is 27. This is something you should note. Okay, the reason I actually know this is because I've practiced this many times. Okay, now what's the atomic mass of sulfur? 32. Now what's the atomic mass of oxygen? 16. And what's the atomic mass of hydrogen? 1. So the next step, we solved for atomic masses. So if I want to solve this formula, my atomic mass, getting atomic mass will not be a problem. So the other is number of atoms. What does this imply? It's very easy. So let's get the number of atoms of each of the elements in this compound. Very, very easy. So let's work towards aluminum. Okay, first of all, okay, but we actually need just one of them in this question, because they're asking specifically for oxygen. Do you get? But I have to solve everything in case. Now, aluminum atomic mass, a number of atoms, meaning that how many aluminum can you see in this compound? How many can you see? 2. I saw only 2 aluminum, so here become 2 atoms. Do you understand? Very easy. Now, how many sulfur can you see as well here? It's actually very easy because here I saw S, and this 3 inside this bracket shows that 3 is affecting everything inside the bracket. So definitely, and it is times. So definitely we have S3 now. Yeah, because 3 times S is S3. Do you understand? Or 3S. Do you get the point? So my point here is this: in this context, now we're having 3 sulfur. I hope it's clear. It's actually very easy. It seems for me to solve this question, let me restructure this particular compound because I don't want any situation whereby you not be finding it difficult. Very easy. Now let me restructure it in the sense that we're already having Al2. It does not change. Now, since we are having a number outside the bracket, let's use this number to times everything inside the bracket. Then we are having S3 because 3 half times this guy, S3. Now we're having 4 oxygen before, but 3 times 4, what's that? 12. 12. So in general, now we're having O12. Do you understand? You have to use this number to times everything to make it very easy for you to understand. Dot your 2H2O, which does not change. Do you get the point? It's actually very easy. So the next step is to now calculate the number of atoms of sulfur. So in this context, I think this will best for us to get a number of atoms of each of them. So in this context, how many sulfur can you see? 3. So here for sulfur, we're having 3 atoms. Okay, now let's work for the part of oxygen. We have to be very careful. Now, if you observe in this left, because this compound is of 2 sides, we have the water part of it, the water of crystallization part of it, and then we have the other part of it, which is left, and it's separated by dots. Listen, this dot signifies plus. Do you understand? So in this part, we're having 12 oxygen. You get 12 oxygen. And this 2 that is standing in front of H2O, it means that 2 is affecting everything. 2 is affecting both hydrogen and 2 is affecting oxygen. So when 2 affect oxygen, how many oxygen will not get in the right? 2 oxygen, 2, because 2 is affecting it. But if 2 is affecting hydrogen, how many hydrogen are we to get? 4, because 2 times 2, 4. But nothing was here, just 2 oxygen. So now let's get in total the number of atoms of oxygen. So here we're having 12 oxygen. Okay, 12 oxygen here, and here we're having 2. So in general, we're having 14 atoms of oxygen. Okay, 14 atoms of what? Oxygen. I hope it's clear. It's actually easy. It's not difficult. Okay, here become 14 atoms of oxygen, whereby atoms, there must be S. And lastly, we've solved for oxygen because that's what they are asking us to get in this question. Very easy. So how do we now get the number of atoms of hydrogen? Here, if you observe, we're having just hydrogen present here, because for oxygen, oxygen was present in different sides of the compound. So we have to solve it carefully. So for hydrogen, it is just 2 times 2, which is 4. So we're having 4 atoms of hydrogen, 4 atoms. But in this question, which of the elements are they asking us to get the percentage composition? Is it not for oxygen? Yes, we'll simply come here and say percentage composition of which of them. Oxygen will not be equal to, what is the atomic mass of oxygen? The atomic mass of oxygen is simple. According to what we've derived, we say atomic mass is 16. Do you understand? All right, 16 here times number of atoms. What becomes the number of atoms of oxygen? What did we agree to be the number of atoms? 14. Okay, we write it as 14 divided by. Now, another issue here, but it's not a problem, simple, is calculating the molar mass of the full compound. Very easy. So let's get our molar mass. Molar mass, I'll call it mm here. I believe you understand what I wrote. Mm means molar mass. So let's get molar mass. Molar mass is just taking the atomic masses inside and calculating everything. So what's the atomic mass of aluminum? We said 27. And how many atoms of aluminum do we have? We have 2. So 27 times 2. And you know it is plus next. Not divide, not minus. Plus. Sulfur is what? 32. And how many sulfur are we having here? 3. Do you understand? Plus, please try to, it's very easy. I believe you are following. Oxygen atomic mass is 16. So we'll come here and say 16. And how many atoms of oxygen are we having here? We're having 12. So we're having 16 times 12. Do you understand? And this dot here, what does this signify? It signifies plus. So then plus 2 will now be standing again. And this is for H2O. So let's solve for H2O carefully. Okay. H2O, hydrogen atomic mass is 1. We've said that already, times 2. Do you understand? Because we have 2 of it, and oxygen lastly 16. So let's press our calculator and get the atomic masses of each. The molar mass of this compound. Very easy. I mean, I'll use my calculator to press everything once to get the answer. It's actually very easy. It's 27 times 2 plus 32 times 3 plus 16 times 12 plus 2. Okay, into 1 times 2 plus 16 close bracket. I'm having 378. 378 grams per mole. That's the unit of molar mass. 378 grams per mole. Now, this question is very easy. My own is you have to solve it carefully. Master it first before you start becoming very fast solving. Not that you are actually not too, sound solving questions on this and you now be trying to be fast. No. Master first, because practice makes perfect. Do you understand? Okay, you can actually do this. It's very easy. So moving further, we've gotten the molar mass of the full compound. So here is 378 and we've gotten it already times what? 100. So let's press our calculator to get the percentage of oxygen. You can see the question specified only for oxygen. So all of these, you still need all of these to actually solve the question correctly. So what do we do next? 16 times 14 divided by 378. Okay, here is 3, not 5. It is 378. Okay, times 100. What becomes the percentage? I had 59.3% or 59.25. Wow, option D is the answer. Very, very easy. It's not difficult at all. I believe you can solve it. So what I want from you is to solve for the percentage composition of the remaining elements, aluminum, sulfur, and hydrogen. And after solving, you add your answers together. If it gives you 100, know that the other values you've solved are correct, including this one I just solved, which is what now? 59.25%. It's actually very easy. I believe you understand how this particular question was solved. Very easy. Now, if you are joining this community and you haven't yet subscribed, do well to click on the subscribe button and also share these lessons with your friends to help you all improve greatly in anticipation for the JAMB exam. So, question number 3 says, the oxidation state of chlorine in this compound is what? Very easy. Now, before I solve this question, I have to give you some points. You have to note that. Now, I'm going to say them more with my mouth, so you jot it down. You have to note that the oxidation state of hydrogen in most compounds exists as +1. Please note it. The oxidation state, or we call it oxidation number of hydrogen in most compounds, exists as what? +1. Because these are the popular guys you need to solve questions on the oxidation number. And with this example, I believe you can solve others. I'm going to give you one practice questions to solve. So in this particular video lesson, I'm going to give you more of your own practice question. After you can say I've given you for this, I want to give for this as well, and give you questions likely to come out in the JAMB exam. So the oxidation number of oxygen, listen, in most compounds is -2. Because we have oxidation number of oxygen in peroxide is actually different. That's -1. Okay, but in most compounds is what now? -2. We have other informations to note. Oxidation number of group 1 element is +1. Do you understand? That's the point. So I believe with these alone, we can, and the oxidation number of halogen, either chlorine, bromine, fluorine, iodine, is -1. But in this context, they are asking us to get it because majorly these two guys are always in the compound you want to calculate oxidation number for. So it's important you know these two things. Oxidation number of hydrogen in most compound +1, oxygen in most compound -2. But for this, is quite, there's an exception to hydrogen. Okay, there are some exceptions to hydrogen. Please note this. So moving further, let's solve this question. To solve this question, we use an arbitrary rule. There is a pattern, always. Is a pattern you should follow. So we are looking, it's just mathematics. Do you understand? It's mathematics. So we are looking for oxidation number of hydrogen in chlorine in HClO4. So then these are the options, very easy. So then we equate everything to 0. Do you understand? When you have to solve questions under this aspect, always equate it to 0 first for a compound, as you are seeing here. So what did I just say is oxidation of hydrogen in most compound? +1. Do you get? It's actually very easy. Now, plus is plus, we are doing +1. Write the sign, don't just say 1, +1 for hydrogen. Plus again, what are they asking us to get? It's not the oxidation state of chlorine, or make it X. I believe you are following. Now, plus, that's the next thing you should write. And oxidation state in most compound is what? What did I say? -2, but put it in brackets so you don't confuse. -2. Do you understand? -2, that's for oxygen. Now, how many oxygen atoms are we having here? 4. So it's going to be -2 times 4. Do you understand? -2 times 4. Do you get it? Simple. It's very easy. It's equal to 0 as well. If here was H2, for instance, it's going to be +1 times 2. Do you understand the point? So next step, we take, here is +1. We write it +1 plus X. Now, plus minus is minus. So minus retains. -2 times 4, that's -8. So here -8 is equal to 0. So the next step, we bring out this equation, +1 plus X -8. okay, is equal to 0. So let's make x subject of formula. When -8 crosses the equality sign, because we're having a 0 here still, when it crosses, we're having +8. And when +1 crosses, we have -1. Do you understand? It's simple. So the next step is x now, because of 0 is negligible, it's going to be +8 minus 1. So 8 plus 8 means 8 minus 1. What's that? It is 7. But since we're having 7, 7 is positive. So it gets +7. Do you understand? I believe this said is clear. Do you understand? The reason I said you have to be careful with your sign is because that +7, you might see -7 in the option. So you have to be careful and write out the correct sign. And it's easy, just follow the step. And I said that to get oxidation number of elements in a compound is determined by some set of arbitrary rules. These two things I just said is going to help you. Do you understand? The oxidation number of hydrogen in most compounds is +1. For oxygen in most compounds as well is -2. But in peroxide, it is -1. While for this guy, which is hydrogen, hydrogen in most compounds is +1. But hydrogen in hydrides, it is -1. There is a reason to all of these, but most times the one JAMB really tests on is all of these guys that are common. Do you understand? So follow this step, you will be able to get it. Now the next thing I want to give you now is for you to solve yours. Now solve for this. Solve for the oxidation state of sulfur in H2SO4. You are looking for sulfur. Please follow the same step. First of all, equate it to 0. You are looking for sulfur, you can do it because I've given you the oxidation state of hydrogen already and given you for oxygen. So solve for sulfur. Get the value for oxidation number for sulfur. Very easy. So let's get into the next practice question. And it says neutralization involves a reaction between H3O+. Now H3O+ can also be regarded to be H+ for the concept of pH calculations, okay? H3O+ is called hydronium ion, whereby H+ is called hydrogen ion. What's neutralization reaction? Is a reaction whereby an acid reacts with a base. This is an acid. H+ is an acid. React with a base like OH-, then what are we getting? We'll get salt plus water. Do you understand? So to determine if something is going to be a base, you'll see OH-. So what is the answer to this question? Neutralization involves a reaction between H3O+, which can also be H+, which is an acid, plus what? OH-. OH- is the answer because anything that has OH- signifies that it is a base. I believe this concept is clear. It's very, very easy. So let's get into the next practice question. Okay guys, moving further, let's get into the next practice question, and it says the reaction of an alkanol with an alkanoic acid in the presence of concentrated H2SO4 will produce. Now this question is very easy, and from the look of things, this particular question is from the aspect of chemistry called organic chemistry. So how do we solve this question? First of all, they say the reaction of an alkanol. You have to understand that alkanols are organic compounds, and alkanols have their general formula to be this. This is alkanol. This is their general formula. It is simply arrow bond OH. When I see this for any compound, it tells me that, okay, this particular compound is an alkanol reacting with an alkanoic acid. And this is for alkanoic acid, what I'm about writing now, alkanoic acid. Now, the general formula for alkanoic acid is simply arrow. Now, please watch. There's something I want to write here. For alkanoic acid, is simply arrow COOH, but structurally, it is written as arrow bond. What's the next? Carbon. And carbon is bonding to oxygen here with a double bond. Note this. Is bonding with oxygen with a double bond, which you are seeing, and this same carbon is bonding with this last group called OH. Please note this. So this OH and this, they are actually not the same. Do you understand my point? So my point here is this: the reaction between an alkanol, which you are looking at here, and also an alkanoic acid in the presence of concentrated H2SO4. This is the catalyst used for this reaction. And the product gotten determines the name of this reaction. I'm going to say something here. So what do we do to solve this question? Simple. So how do we even get the product of this reaction? Very easy. Now, I'm about eliminating something from this reaction. And it's actually very easy. Look at what I want to eliminate. I'm eliminating hydrogen here and also eliminating OH here. I believe you are following. So I've removed H and OH. So when I remove that, at the end of this reaction, what do you think I will get? I removed H bonding with OH. So what's this? What do you think this is? This is H2O, because now we are having 2 atoms of hydrogen and 1 atom of oxygen. Are you following me? So this is H2O. So let's try to join whatever is remaining here to get what should be here, and I'll tell you the name of what we want to get here. Very easy. Now, what is remaining? Arrow bond O, right? And what is remaining here? Arrow C double bond O remaining, right? So look at this. We'll first of all write this part first. That's how it works. So here will be arrow bond C double bond O bond. There should be a bond here as well. Okay, there should be a bond because carbon is tetravalent. It is 4 bonds that are supposed to surround carbon. Let's count the bond surrounding carbon. 1, 2, 3, 4. So I can't just say here we are done. No, it doesn't work that way. Carbon is tetravalent. There is 4 bonds that are supposed to surround it. And what should occupy this part of that? This is arrow O, and actually works like this. O arrow. Do you understand? Arrow, I can actually just remove the bond and just put it at O arrow. Do you understand? So this got in now. If I want to condense it, it is actually arrow C O arrow. Do you understand? Now this got in is the general formula of what we call esters, and esters are also called alkanoates. Do you understand? Esters are also called what? Alkanoates. So what becomes the product begotten in this particular reaction? Option B. The reaction of an alkanol with an alkanoic acid in the presence of H2SO4 as the catalyst give rise to an alkanoid or an ester. And I believe you saw how I got it. It's very easy. But most of the times, this question might actually come out in the exam. So just memorize it, know the answer. Now, this reaction has a name. From here to here to here, it has a name. It's called esterification. Esterification. The reaction between an alkanol and a what now? An alkanoic acid is called what? Esterification. It's actually synonymous to neutralization reaction in inorganic chemistry, whereby we react what? An acid, an inorganic acid with a base. This one is serving as the inorganic acid. This one is also serving as the base as well. Okay, we'll get ester, which is called alkanoid. And you remember, esters have a very pleasant smell. And there's one ester that smells like banana. That ester is called pentyl ethanoate. Do you understand? Pentyl ethanoate, the ester that smells like banana. While the ester that have an orange smell is called octyl ethanoate. Please note this. These are likely questions in the JAMB exam. So that's for that. So question number 6 says, the compound contains, now they're asking us what type of hybridization is seen in this particular compound. Very easy. Now let me give you a trick to get questions under this aspect. We have compounds that are single bonded, we have compounds that are double bonded, and also compounds that are triple bonded. Compounds that are single bonded, their hybridization is sp3. Compounds that are double bonded, hybridization is sp2. And lastly, compounds that are triple bonded, their hybridization is what? Sp. On this note, if you observe, you can see that in this particular compound, even if you don't even know the name of this compound is called methylbenzene. Why did I call it methylbenzene? Very easy. We just watch closely. This CH3 is an alkyl group and it's called methyl. And this removing CH3 is called benzene. So bringing it together is called methylbenzene, popularly called toluene. Now, what type of bond is seen in this particular compound? I have 2 types of bond. I have single bond. Are you not seeing the single bond? And also I have single bond, and also I have double bonds. Double bonds. And also here is single, but these ones they are double. So what did I just say? Single bonds, sp3, double bond, sp. So look for the option that has sp3 and sp. Hybridization, so that becomes the answer. Option A, sp3 hybridized carbon atoms only. No. sp3, sp2 hybridized carbon atoms. Yes. Option C, sp. No, it can't be sp. It is option B. So when you see other questions like this, you can actually solve it. Even if it's not actually benzene, it's any organic compound. Just look at the bonds present in the compound and then try to get your answer. And it's very easy, like ABC. So that is for that. So let's get into the next practice question, which is CH3, CH2, CH bond this, and that. They are asking the IUPAC nomenclature for this compound is what? They're asking us to name it. Very easy, very easy. So let's name it together. We'll do it from scratch. I'm going to teach you the rudiment. I have video lessons on my channel that explains about IUPAC nomenclature. So it's important for you to go watch that lesson. But in this particular question, I'm still going to break it down from the scratch on how you can actually solve this particular practice question. So the first step here to solve this question is to write it out again. Now, if you observe, here is CH3. We write it as what? C bonding with, like, CH3, here is CH3, this structure of CH3. I want to write everything structurally so it will be easy for us to name. Now, this CH3, this CH3. Do you understand? CH3. Bonding with what? CH2. I will do that. Bonding with what? CH2. Do you understand? This is the CH2. Bonding with what? CH. C, leave that H first. And if you observe, there's H, there's OH. That means this particular compound is bonding with OH up and also H down. Though that H was here before, but want to write the structure, so I'll remove it and put my H down. I believe you are following. It's actually very easy. Now, the next step here is that this carbon is still bonding with CH here. I'll do that. CH. But should I actually do that? Just hold on. Watch closely. That CH is bonding with that H. I want to bring it up. Remember, we are drawing the structure. I want to bring that H up. So when I bring the H up, what's remaining? What is remaining? Watch closely. CH3 in a bracket. And we're having 2 outside. That means we have 2 CH3 here. So which particular part of this compound will it occupy? Remember, we have 2 CH3 here. But remember, I told you that carbon is tetravalent. How many bonds are supposed to surround carbon? 4. So how many bonds have surrounded this carbon now? 2. So how many bonds remaining to be completed? 2 bonds. So that carbon is correct. So let's impute the 2 CH3 group remaining. I believe you understand what I just did. It's actually very, very easy. Very easy. So the next step is to identify. Now, this is where I want to start from the video lesson uploaded on my YouTube channel on how to name organic compound, be the type of organic compound. Very easy. So what do we do next? We identify the longest continuous carbon chain. And how do we do that? We have to look at the carbon-carbon connection to see the one that is the longest. So if I count 1, 2, 3, 4, 5, this carbon-carbon connection, I have 5 carbons. Let me look at this direction. 1, 2, 3, 4, 5 is still like the same number. So we've seen that I've identified the longest continuous carbon chain. So let me like show you guys what I've identified. So in any direction I count, you can say I had 5 carbons. So then let's just take this horizontal fashion to be the longest continuous carbon chain. This can also be the longest continuous carbon chain, whereby CH3 at the end will be a group or a substituent. Remember, I've explained all of this on my YouTube channel on how to name organic compound from the scratch. So it's important for you, after watching this video to the end, go watch that particular video lesson to understand all of these aspects very well. So let's progress. So what do we do? Very, very easy, class. Identify the longest continuous carbon chain. Now let us number this longest continuous carbon chain. We'll number in 2 directions. We'll number forward and also number backward. So let's number forward. 1, 2, 3, 4, 5. Let's number backward. Now let's number backward. It's going to be 1, 2, 3, 4, and 5. Do you get? Now, before we progress, we have to now look at the groups attached to this compound to get the one that will be the parent name. Now, if you observe, I have CH3 as a group and also I have OH. So what do we now do? We have to understand that OH and CH3, when it comes to priority, which one is higher? OH. OH is senior to CH3. So the parent name of this compound become an OH. And anytime we hear OH, our mind should go to alkanol. So definitely it should be an ol. Do you understand? The compound's name should end with ol. Do you understand? It should end with ol. Now, I said it should end with ol. Do you get? So put that in mind. So what do we do next? We have to now look at, okay, we have 5 carbons. We've counted forward and backward. So since we are making this to be our functional group, listen carefully. Since we are making this to be our parent name or functional group, then we have to make sure our counting favors the functional group in the sense that, listen, in the sense that the number that should be ascribed to the functional group should have a very low number as possible. So if we counted forward, you can see I got, listen carefully. Since we counted forward, listen, now we counted forward, we saw that at carbon 3 we have OH. We counted backward, we saw that at carbon 3 also we add OH, which is the functional group. So then we are okay. Now I've looked at that part. So let's look at our substituent. We have to still make sure that our substituent have a low number. So if I count forward, you can see that our substituent group is in carbon 4, but if I count backward, is in carbon 2. So which direction to which we count? We've agreed that any direction we count for our functional group, we have 3. So then functional group does not have a problem here. Another problem that we have to solve is in the CH3 group, which is substituent. We have to make sure that it has a very low number. Okay, that's what we have to make sure it has. So on these notes, So if you say you counted forward, add 4, counted backward, add 3. So which one should I go for? The one with 2. So then this forward direction will not work. Then we'll focus on backward direction, because add carbon 2, I add 2 methyl. Do you understand? 2 methyl. And definitely this compound has 5 carbons, so it should be called pent. That should be the parent name, pent. Okay, paint, put that in your mind. Add carbon 2, we have methyl, so we have 2 methyl. Okay, and no other substituent, so let's just give it a parent name. So 2 methyl penta, that's word. 2 methyl penta, you know, anything 5 carbon is pent. Penta, how many all? How many all? Which shows that this compound is an alcohol. How many all? 3 all. 2 methyl penta, 3 all. Do you understand? 2 methyl penta, 3 all is the name of this compound. Very easy. Go watch my video lesson on IUPAC nomenclature on my YouTube channel to understand all of these things. I've made them very easy on my channel. So let's check the option. Option A was 4 methyl penta, 3 all. Wrong. If you observe, they counted forward. That's why they choose up. That's why they said option A was an answer, but it's not correct. Option B is 2 methyl pent, 3 all. That's the answer which we got. Option C is 2 methyl pentanoic acid. Is this an alkanoic acid? No. Alkanoic acid is RCOH. Are you seeing anything like this in this compound? No. So then option B becomes the answer. So let's get into the next practice question. Which is question number 8. It says sodium metals give dash flame on testing. So it must be noted here that the flame to which sodium metal give is golden yellow. Take note, the flame for sodium metal is golden yellow, and it appears invisible when you view it with a blue glass. Take note of this. The flame test for sodium is golden yellow and appears invisible when you view it with a blue glass. So the next practice question says electrolytic cell convert dash to dash. Electrolytic cell converts electrical energy to chemical energy. This must be noted. Electrical energy to chemical energy. Note that. Now, what are electrolytes? Now, simple. Electrolytes are compounds. Electrolytes are not elements. Electrolytes are compounds that conduct electricity when they are in liquid form. So if you observe, the only state of matter to which electrolytes can work is when they are in liquid form. Do you understand? So we have two groups of electrolytes. We have strong electrolytes and also weak electrolytes. Strong electrolytes, from your strong acid definition, they are compounds that ionizes completely in a solution. Example, strong acids, strong bases, and salt. Strong acids like HCl, HNO3, H2SO4, whereby strong bases like sodium hydroxide, which is NaOH, potassium hydroxide, which is KOH, and also salts like sodium chloride and also KHSO4. All of these are examples of strong electrolyte. Please note all of these I just said, because they might actually put it in the exam hall. So please note all of these. Whereby for weak electrolyte, they are compounds that ionizes partially in a solution. Examples include your organic acids, include amines, include water. All of these, and even ammonia is a good example of a weak electrolyte. Do you get organic acids like formic acid, also called metanoic acid, and also ethanoic acid is a what now? Is a weak electrolyte. All acids, all organic acids are weak electrolyte. So that's for that. So question number 11 says in an electrolytic cell, anode has a positive sign. Take note, we have electrolytic cell whereby we have two electrodes, be it an electrolytic or an electrochemical cell. For electrolytic cell, the electrodes are two, which is same for an electrochemical cell, which are cathode and anode. For electrolytic cell, cathode is negative, anode is positive. For electrochemical cell, it is the opposite. It is the opposite, whereby this anode that is positive in electrochemical cell, it is negative, whereby cathode now is now what now? Positive for electrochemical cell. I believe you understand what I'm saying. It's actually very easy. So the next question says the heat content of a reaction. If I were to draw the reaction, the diagram, you see all of these things. Okay. So the next question says the heat content of a reaction is called enthalpy. Enthalpy symbolized as H. Do you understand? But if I'm to talk about enthalpy change, it's going to be delta H. Do you get? That's for that. So let's progress to the next practice question, and it says how is radioactivity applied? Radioactivity is applied in so many fields. Radioactivity is applied in the field of medicine, is applied in agriculture, is applied in so many fields. Now, in the field of medicine, it is used in treatment of cancer, people with cancer, people that are malignant. Okay, and this is done using a very radioactive element called cobalt-60. And also, it's also important for treatment of people with thyroid, what do you call it now? Goiter. which is the disorder of the thyroid gland, which is located in the neck region. Now, this is done using a very important radioactive element called iodine 131. Iodine 131. That is why individuals who are deficient of iodine can basically result in this goiter, specifically exothermic goiter. Do you understand? Which has to do with the over secretion of this gland, which is the thyroid gland. Okay, that's for that. Let's progress. So also it's applied in the treatment of leukemia using phosphorus 32, and also it helps as it serves as a pacemaker for people with weak heart, and also it's also used in the what do you call it now, for sterilization of surgical instruments, and also used for detecting fracture in bones. That's X-ray. Do you understand? So this is how radioactivity is applied. Okay, and also applied in agriculture to actually induce mutation in plants. Do you understand? And also applied in radiocarbon dating to know the age of a particular artifact. Okay, that's for that. So let's get into how electrolysis is applied. Electrolysis is applied in so many fields in the preparation of some compounds, purification of metals, and also electroplating, which is also called cathodic protection. Do you understand? Electroplating can be of any kind. It can be either silver plating, can be either zinc plating, also called galvanization, gold, and so on and so forth. So all of these must be noted. Though there are some things to this application of electrolysis, but all what I just said is very important. Note that zinc plating is also called galvanization. And the next question says the basicity of HCl is monobasic. This is HCl as an element. So when we split it, we'll get H plus Cl minus. So at the end of splitting it, how many H plus did we get? Because the reaction is balanced, we had one H plus. So we say that this compound is monobasic, or monobasic, and the basicity is what? 1. So all these must be noted. So let's get into the next practice questions. Let's get into the next practice question, and it says the process whereby a heavy nucleus is split into two nuclei of nearly equal masses with the release of energy is what? Is very easy. Now, in the look of things, this particular question is from the topic in chemistry called radioactivity. And when studying radioactivity, we have two important reactions to be noted. The first one is called nuclear fission, whereby the other one is called nuclear fusion. Now, on this side, from the word fission, it has to do with splitting, breaking, fission. While from the word fusion, it has to do with joining together. So if you check the process here, it said whereby a heavy nucleus is split into two nuclei of nearly equal masses with the release of energy. What reaction should be this? This is called nuclear fission. Do you get? So this must be noted. Whereby question number 17 says, dash step in water purification prevent goiter. It is very easy. The answer is iodination. Do you understand? It's important for that water to be, there must be application of iodine in that water to prevent goiter. Remember, goiter has to do with the disorder of the thyroid gland. Do you understand? The thyroid gland is an endocrine gland. Remember, endocrine glands are ductless glands whereby they release these hormones. Do you understand? These hormones goes directly into the bloodstream. Okay, unlike exocrine gland, which basically they are regarded to be also called duct gland, their secretion passes through a duct like the salivary gland, like the sebaceous gland. Do you understand? So all of these must be noted. Okay, so for the biology student, remember that endocrine glands include the pituitary gland, the pancreas gland, the adrenal gland, the thyroid gland. Do you understand? Pituitary of 2, we have the anterior and also the posterior pituitary glands. Do you understand? And they have specific hormones to which they produce. Okay, so let's get back into these questions. Whereby question number 18 says, proton donor they are regarded to be called acids. Okay, whereby proton acceptors are called bases. Now, let me explain this. Okay, it's very important for you to note the explanation. Now, it's actually very easy. Remember, we said that proton donor are acids. Now, let's take an example. Let's take an acid, HCl, and we'll break it or dissociate it. I am to get H plus plus Cl minus. Do you understand? So, at the end of breaking this guy, which is an acid, we got H plus. So, this acid donated the H plus. Do you understand? So it means that acids are proton donor. They don't like it much. They have it in excess. So they have to donate it. That's what it means by proton donor being acid. So this H plus basically is the proton we are talking about here. H plus can also be divided to called proton. Hope you get H plus also called proton, whereby for proton acceptors, there are bases like this base, which is ammonia, NH3. So when reacting with the H plus, which is a proton, then we have to have NH4 plus. So on this side, note this, if you observe, bases are proton acceptor. They always accept it, they like proton. So then it forms this. We have other reactions example. Do you understand? This is just an example. So on these, 20 says electron pair acceptors are acid, whereby electron pair donors are bases. Do you understand? So on these, this must be noted. It must be noted here that these two definitions was given by two scientists, Bronsted and Lowry. Their full name, Johannes Nicholas Bronsted and Thomas M. Lowry. That's their full name. So they brought it, the Bronsted and Lowry concept of acid and base, whereby these two definitions, being electron pair acceptor and electron pair donor, was given by a scientist called Gilbert Newton Lewis, G.N. Lewis. And this definition is the most encompassing definition of acid and base, because there's so much to learn here on this definition. But this I just said is important, okay, this must be noted. There's so much here. Do you understand? So on the next question, it says the acid used to remove rust from metal is HCl. Okay, though we have other acids, but this is done chiefly. Okay, this is the acid that is used to remove it chiefly. Now, moving further, the above process has a name and it's called pickling. Pickling, that's the process to which an acid is used to remove rust from metals. So, question number 24 says, HCl is not a strong acid. True or false? Here should be false. So, they're asking us if this statement is true or false. The statement is false. It is false because HCl is a strong acid. Remember, strong acids are compounds that ionizes completely in a solution. Examples of strong acid include HCl, HNO3, or what do you call it, H2SO4. All of these are good examples of strong acids. Okay, so HCl, it is a strong acid and it's not a weak acid. Okay, so that's for that. So 25 says the acid used to make explosives like TNT, rather here should be like TNT, specifically is called HNO3. TNT is called trinitrotoluene. Is HNO3 that is used to do that, which is called aquafortis or nitric acid or trioxynitrate 5 acid. Okay, whereby 26 says the base used to manufacture hard soap is sodium hydroxide. That's the base used to manufacture hard soap. Whereby 27 says the base used to manufacture liquid soap is KOH, potassium hydroxide. Okay, whereby 28 says the chemical bond that results in the transfer of electron is called electrovalent bonding, or we can say electrovalent bond. That's the chemical bond that results in the transfer of electron. We have another one which results as a result of the sharing of electron. That is what we call covalent bond. Do you get? The bond that has to do with transfer of electron, it is electrovalent bond. Remember, bonding, chemical bonds of two groups. We have the intramolecular bonds and also the intermolecular bonds. Intra, there are 3 groups. We have the electrovalent bonding. Electrovalent bond can also be called ionic bond. We have covalent bond, and also we have metallic bond. Do you understand? We have metallic bond. And we've said what they are talking about. So question number next says, when the electronegativity difference between bonds are large, what bonds could result? It's actually very easy. When the electronegativity difference between bonds or atoms are large, it as a result of what? Electrovalent bond. Though there is a reason to this, but note it now. Okay, but what becomes the opposite when the electronegativity difference between these two bonds are small? Which type of bond do you think will result? It is one I just said, which is called covalent bond. Do you understand? So you have to note 2 things about covalent. Covalent has to do with sharing of electron and electronegativity difference being small, whereby this has to do with transfer of electron and electronegativity difference being large. You actually appreciate it more when I explain all of this, but it's important for you to note this very well. Okay, so question number 30 says the shape of CO2 has a linear shape. Okay, linear shape, like straight line. And what's the angle of a straight line? It is 180 degrees. So what becomes the bond angle of compounds with linear shape? 180 degrees. Very easy. Because question 31 says the bond angle of methane. Remember, methane has a tetrahedral shape. And the bond angle is simply 109.5 degrees. Okay, whereby 32 says the bond between water and ethanol. This is ethanol. How do I know it's ethanol? I am saying OH, which signifies it is an alkanol. And I saw 2 carbon, which is eth. Remember, I've said it on my video lessons on YouTube on how to name organic compounds. Compounds with 2 carbons you should call eth. So then this is ethanol. So the bond between water and ethanol is called hydrogen bond. Hydrogen bond. And we classify bonds into 2 groups, inter and intra. For the intra, we said they have electrovalent, covalent, and metallic, whereby inter include what we call hydrogen bond, van der Waals forces, London forces, dispersion forces. So the bond that exists between water and ethanol here is hydrogen bond. Now we have other substances to which hydrogen bond are present. Now the bond that exists between the layers of graphite is hydrogen bond. Remember, graphite, it is a what? An allotrope of carbon, specifically a crystalline allotrope of carbon. Do you understand? And not only the layers of graphite, it also exists between iodine and naphthalene crystals. Do you understand? So that must be noted. 33 says the colored ion of transition metal. So this is hydrogen bond, whereby the colored ion of transition metal is as a result of them having partially filled d orbitals. Remember, we have different orbitals in chemistry, the s, p, d, f orbital. So them having or forming colored ion is as a result of this orbital being partially filled in them, and they exist between group 2 and group 3 elements of the periodic table. It's actually easy, okay? But just note what I just said. You actually appreciate it more when you see that they have partially filled. You see it, they have partially, but it's important for you to notice that they have partially filled the orbital transition metal, and this is the reason why they form colored ion, they form complex ion, they have the ability to act as catalyst. These are some reasons to which why they are transition metals, and they have partially filled the orbitals, whereby 34 says element that ionizes by loss of electron they are called metals. But if I were talking about the opposite, which is gain of electron, they will be non-metal. So element that ionizes by loss of electron, metals; gain of electron, non-metals. Okay, so this must be noted. So let's get into the next practice question. Okay guys, so let's get into the next practice question, and it says discovery of X-ray was by a scientist called Wilhelm Röntgen. Take note of this, Röntgen. That is why X-ray is also called the Röntgen's ray, whereby discovery of atomic number was by a scientist called Henry Moseley. Do you get? And question number 37 says elements in the same group of the periodic table, they are called cogeners. If you observe, looking at the word gene, if you know little biology, you see that gene has to do with resemblance. So elements in the same group, they have the same property, they have the same chemical property, they behave the same way, so they are regarded to be called cogeners. Okay, now physical property of acids. What are the physical properties of acids? First of all, acids, they basically turn blue litmus red, and also they have the pH value that is lesser than 7, and also concentrated form of acids are corrosive. Do you understand? While for the physical properties of bases, let's talk about what we just said for acid. First of all, on what happens to litmus for bases, they change red litmus blue, and also they are soapy to touch. Concentrated form of them are corrosive, and they have the pH value that is greater than 7. Okay, that's for that. Whereby question number 40 says when delta G in a reaction is negative, what does that mean? It means that that reaction is spontaneous and that reaction can occur on its own. But if it is positive, it means that reaction is non-spontaneous and cannot occur on its own. All of these are factors that determines if a reaction will be spontaneous or not. First of all, what is delta G? Delta G has a name. It's called Gibbs energy. Gibbs energy. We have all of these, they are regarded to be called state functions. Okay, they call them state functions, not just Gibbs energy. We have this other one, which is enthalpy. We have entropy. Entropy has to do with the degree of disorderliness in a system. I have video lessons I've explained on each of these concepts, entropy, like that, many topics in chemistry. So if you haven't yet watched those lessons, make sure you watch those lessons. It will help you improve greatly in your studies. I wish you all success in your exams, and I anticipate your testimonials. God bless you all, and thanks for watching.